Welcome back 7th and 8th grade. We are continuing our discussion from section 5.34 on the senses. Any guess with Dumbo here behind me what sense we are talking about next? If you guessed sense of hearing, you'd be right. So your sense of hearing comes from obviously your ears, and your ears have three main parts. You have an outer ear, a middle ear, and an inner ear. And what happens is that sound waves travel through the ear canal to what's called the tympanic membrane. You're probably more familiar with this as being your eardrum. And those sound waves cause vibrations that vibrate tiny bones we find in the middle ear. Okay, so this is all the result of vibrations of the bones in your ear. And you have three super duper tiny bones in your ear. And so when we talked about the skeletal system, I mentioned these, but these are called the ossicles, and they have three different names. There's two names for each of the three different bones. And so your textbook is calling them the hammer, the anvil, and stirrup, and so those answers would always be accepted as correct. But also the hammer is known as the malleus, the anvil is known as the incus, and the stirrup is known as the stapes. So the malleus, incus, and stapes. And you can see those here in this image. Okay, so they're showing you this is your tympanic membrane or eardrum. You have the malleus here, this whole bone right here. You have the incus, which is this bone right here. And then you have the stapes, which is this bone right here. And to give you guys a sense of just how small these are, this is what they look like. So that's obviously a fingertip, and they don't even cover the little top portion of your fingertip. So they are very, very, very small. If any of you ended up going with mom or dad to see Body Worlds at the Boston Museum of Science while it was visiting us for several months this past year, they actually had three of these three bones on display, and it was very cool to see because, man, they really are super small, and they make up your middle ear. So the stirrup, okay, that bone vibrates what's called the cochlea in your ear. And the cochlea is a snail-shaped organ in your inner ear that's filled with fluid. All right, and you've probably heard before that you have fluid in your ear. And you want the right amount of fluid, because if you have too much, then that's when you can hear that sloshing in your ear. Or if you get sick or have a cold, oftentimes we get excess fluid in our ears, and that's where you can't hear right, or there's crackling and popping, and boy is that annoying if you've ever experienced that. These vibrations, as we said, produce waves inside the cochlea here, and neurons convert those waves into electrical signals. So this does go all the way back, as always, to the nervous system. Those neurons interpret those waves as electrical signals, and then the brain will say, hey, those waves and those signals, they're going to come out as a certain sound. And so they interpret the signals as sound, and that's how you hear all the things that you hear. Your ear is also involved in your sense of balance, and maybe you've heard that before, or you've experienced that if you're someone who gets motion sick and you've experienced your equilibrium or your balance being out of whack. And this is because you have semicircular canals in your ear that control balance. And these semicircular canals are lined with little microscopic tiny hair-like structures, okay? And it is also has that fluid in it, okay? And so when you move your head around and you shake your head around, those tiny hairs and fluid move around as well. And it produces those nerve impulses that travel to your cerebellum, okay, that part of your brain. And your cerebellum then sends messages to muscles throughout your body to adjust for your loss of balance. Okay, so if you go and you spin around a bat like 10 times on the ground, like in some games where you put it on your forehead there, and get up, you're quite dizzy, right? And that's because your brain is trying to catch up with these hair-like structures and fluid and the impulses that your nerves are sending, but you're so jumbled up, there's a bit of a delay in regaining your balance, and so that's why you wobble and you can't walk straight. And a similar thing happens to those who get motion sick in the car. It's not everyone is susceptible to that, of course, but if you are, it has to just do with your brain's ability to balance and rebalance your equilibrium and get a sense of what you're seeing through your eyes and the messages that are coming through your ear. And when there's a loss of translation between those two, that's when you start to get sick and you can't stand up straight or you're puking. Okay? You've also probably heard or may have heard of something called the eustachian tube before, and this is the air passageway between the middle ear and your throat. So if you did not know that, your middle ear is connected to your throat, which is often why you may experience that clogging of your ears or the crackling of your ears when you have a head cold, because you may be having that postnasal drip in your throat and in your sinuses and in your nasal cavity as well as in your ear, and that's all through the eustachian tube. Okay, and so this is a much more complicated diagram of an ear than what we are, of course, studying, but I wanted you to see here what we're considering the inner ear, the innermost portion of your ear here, where you see that eustachian tube that connects to your throat. You see that snail-looking organ here, that's your cochlea that we just discussed, and the semicircular canals. Okay, and you can also see those three bones we talked about, the ossicles. You have the stapes, the incus, and the malleus, all right here, the ossicles. All right, and then here in the middle ear as well, in addition to the ossicles, you have your eardrum or the tympanic membrane, which then leads its way out into the outer ear, which is the part of the ear that we see on the outside of our body. And you have some different structures in here that make up your ear. All right, what about a sense of smell? So your sense of smell is more officially known as your olfactory system, which means to smell. Okay, and you have receptors that are located high up in your nasal cavity. So that's, up above your nose, to the left and right of your nose, and all of your sinuses that make up your skull. And those receptors are going to react to chemicals that are inhaled in dissolved air. Okay, and so we're not just talking about strong chemicals here like ammonia or bleach or something. We're also talking about just natural chemicals of smells, of flowers, of food, of those cookies baking in the oven. All of these are considered dissolved chemicals in the air. And those chemicals travel to the nerve axon endings, there's that nervous system connection again, through tiny holes in your sinuses. So your sinus cavities have these microscopic holes where these chemicals travel to, and they're able to reach the nerve axon endings. Okay, so those terminal axon terminals on the axon structure that we've studied. And most neurons in your brain are permanent, but those that sense smell are actually replaced about every 2 months. Okay, so while we don't replace many of the neurons in our brain, we do replace those that are involved in the sense of smell. Okay, and so here's just a little bit of an image to show you this person sniffing a flower, and those aromatic substances are those chemicals that we're talking about. And they're going to go into the nasal cavity, and you've got some sinuses up in this region and in this region here as well. And they're going to communicate with a part of your brain that we did not study called the limbic system, but it's going to communicate with your brain on those axon terminals to send those signals for your brain to interpret the smells as either really pleasant or maybe some not so pleasant smells. Okay? Your sense of taste. Your tongue, as you guys know, contains taste buds, but it actually has these tiny projections on it called papillae. Okay, and these papillae have the taste buds in it in groups of about 50 to 150 taste cells around a particular taste pore. Okay, so this taste pore is just a small opening on those papillae with all these taste cells in it. And they sense any dissolved chemicals in your saliva and send electrical impulses to the nearby nerves. And those nerves, just like with the other senses, send signals to the brain, and now we can experience taste. And as you guys know, many people have different ideas of what tastes good or does not taste good, and that's just one of the many ways that God has made us all unique and different. And our DNA and our genetics say a lot about the foods that we prefer and don't prefer. On a side note though, most of us often give up on saying we don't like a certain food far too quickly. Research indicates that you actually need to be exposed to something about 7 to 12 times before you can actually make up your mind, or before your brain can actually make up its mind on whether you like something or not. So if you're a picky eater, I encourage you to continue just trying small amounts of foods that you may think you don't like, or try them in prepared slightly different ways, and you might be actually able to expand your palate on a scientific level and on a physiological and body level, and be able to enjoy more foods. And this is something that a lot of nutritionists advise new parents who have young children as they're trying new foods for the first time. Often, if you've ever seen a baby try like a lemon or some mashed spinach for the first time, they make that horrific face and they don't know what to take of it. But it's important to keep giving repeated exposure to foods because our taste buds are constantly changing, and our brain is changing the way we sense that information as we eat. Okay, and so here's just a formal structure of what those taste buds look like. This is a one taste bud here. All right, and it's obviously more complex than we're going into, but you can see that taste pore is right at the top. And you can see here we have the papillae all over your tongue, and those have those taste buds in them. On the topic of taste, there are 5 major tastes, okay, that we on our tongues can interpret. The first is sweet, the second is sour, third is salty, the fourth is bitter, and the last one is called umami, which is probably the one you've not heard of before. And this is just showing you some examples of what things your taste buds would interpret them as. And although this is showing you certain regions on your tongue where you can taste these specific feelings, or taste these foods and different tastes and flavors, it's only partially true. It's only partially accurate. There are regions that are more heavily able to sense these, but as a whole, your tongue can interpret, or your brain can interpret these tastes from all over your tongue. All right, and that's where we're ending for our senses, for our lesson on our senses. So we are going to wrap up here with a homework assignment. So your homework for your next video lesson is to read lesson 5.34 senses. So read through pages 279 through 83. Take you a couple minutes at most. And then complete your lesson review questions 5.34 and email those to me like you've been doing up to this point. And lastly, you're going to complete worksheet 5.3.4A, eyes and ears, in your workbook, okay? So read and answer these 2 pages, the lesson review questions and the worksheet. Additionally, be sure to check out the videos that I have linked below before completing your lesson review questions, because they will be helpful to you as you do your work. And with that, I will see you guys for our next video. And make sure when you come on for your next video that you bring these completed assignments with you.